Hey, Applied Pre-Cal. Look where I am. I literally just posted the assignment today. Sorry for all the work. Literally just posted it, and I've had two people already ask me the same question. So I thought I might go over one of the parts, or two of the parts to question number 26 on page 385 with you. The question tells you that you should be able to make an equation into general form if it's a linear relationship. If you can't do that, then it's not a linear relationship. So I'm looking at A and B. A, the equation is x over 4 plus y over 3 is equal to 1. And for B, it's y equals 10 over x. Are either of these linear equations? Well, let's see if we can put them into general form. That'll help us figure it out. For A, general form would be ax plus by plus c would be equal to 0. There's two ways of looking at a problem like this one. For one, we can represent these as fractions, or we could represent your fractions as coefficients. If we did that, it would look like this. Okay, it doesn't look great, but it's a lot better than what we started with because it looks a lot more like our general form. It actually ends up looking like standard form. We just got to get that 1 and move it back over to the other side. So if we subtract 1 from both sides, we'll have an equation that looks like it's in general form. Okay, so everything's fine and dandy now. It looks just about right. Problem is that our a value must be a whole number. 1/4 is not a whole number. So to counteract a fraction, you have to multiply the tops of everything by whatever the bottom of that fraction is. So I'm going to multiply everything by 4. I end up getting 4 over 4, 4 over 3, 4 times -1, and 4 times 0. And if I clean it up, my equation ends up looking like this. Technically, you could stop here because you do have a whole number in front of x. We said that it doesn't really matter what's in front of y, but you could actually clean this up. It's a very simple step. You do the exact same thing you did with x to clear up the 1/4 with this 4/3. So you can multiply everything by the bottom of the fraction, which is a 3. So I end up getting 3x plus 3 times 4 over 3, y, minus 4 times 3 equals 0 times 3. And if I clean that up, it looks like this. Ta-da! Yeah, 3x plus 4y minus 12 is equal to 0. That is a general form statement, and we didn't change anything other than working with some of our algebra to get here, which means that this original equation for part A is in fact a linear relationship. B, on the other hand, is a bit of a tricky one because we don't have anything that looks like a standard or general form or any form, to be totally frank. We've never seen an x in the denominator before, but we just work with fractions. If we have a fraction, to get rid of it, we multiply the tops of everything by the bottom of that fraction. So the bottom of our fraction is x. I'm going to multiply everything by x to see if that cleans things up. Okay, and we end up with xy is equal to 10. I would have had 10x over 10. I would have had 10x over x. The x's cancel out, which is why I'm left with 10. So xy equals 10. Does that look like a linear relationship to you? Well, it kind of does. If it was just x equals 10 or y equals 10, we'd have an extreme case. But this is an example where we have two different dimensions, an x and a y, and when two dimensions are multiplying together, you get a two-dimensional shape. Lines do not represent two-dimensional shapes. So unfortunately, this is not a linear relation. And there's no way you can turn this into general form either, because at the moment, x is the coefficient for y. That's not possible for general form. So this is not a linear relation. And I've left C and D for you to try out to see if you can apply the same logic to both C and D. I like this question a lot. This not the same thing, but I'll likely put something similar on your assessment because it's a good show of if you know how to work with the various equations that we have.